Today I want to make a quick overview of logic programming using Prolog, which is a programming language as a support for examples and descriptions. So logic programming is a database and knowledge representation based on formal logic compared to some other models. So the focus here is on the answer more than the way to reach the answer. So basically what we want to get instead of how we manage to get it. Unlike many other programming languages. So some languages exist already, like Prolog, ASP, which is not ASP.NET, but something else, and Datalog. And the main usage, I would say, would be in machine learning and AI, because it's a format that can describe quite a lot of data and concept with fewer lines of code. So, like many languages, there are types, data types. In Prolog, they call them terms. There are not so many types of terms. The first one being the Atome, which is basically a label kind of symbol in usually in one word with a lowercase first character, which is important. If we need uppercase several words and or some specific characters, we usually use quotes to surround those terms. Because the case has importance, we'll see later. Quick question: do you see the mouse cursor? Or
yes,
good. Okay.
Yes,
I might use it at some point. So you have also numbers, which can be floats or integers, and variables. And here we have the importance of the case, because any symbol starting with an uppercase character is a variable, or if they start with underscore and anything after, which is composed of letters and digits. This specific unique character underscore variable name has something special, but we'll see later. And the last type of term is a compound term, which is basically an atom that we saw before, like a label or something more composed, and a list of arguments. So a bit like signature of a method in some other languages. The number of arguments is called arity, and it's noted with a slash and a number for the number of arguments. So basically, an atom has no arguments, so arity is 0. So sometimes it's written like this, like the atom name /0. And there are some specific terms, compound terms, that are a bit more elaborated, like the lists, with the empty list having just 2 brackets, like in many other languages. And otherwise, a list of elements with comma separated. And the strings, there is a little specificity about strings, that they are between double quotes, and the interpretation can change depending on the settings of the engine. Most of the time is to put a bigger sentence, a bigger amount of words. In some cases, depending on configuration, it can be also seen as a list of separate characters. So yeah, It's not always the same. After the types, there is the two main elements of the language, which are rules and facts. Both of them are called clauses, but there is normally a head and a body, except that the clauses without body are called facts. And it's basically knowledge. Well, all of it is knowledge about the world that we want to describe. But the facts have no condition. They are basically true. Like it's a saying. So here you have an example. If we write human parenthesis Socrates period, the period character is very important. It's a fact that we give to the program or to the world that we want to describe. And yeah, it just says this at the moment. It doesn't have any more meaning than the label human with the argument Socrates is true. It's going to be evaluated as true all the time. And the second type of clause is the rule that has a head and a body. So the head is like a compound term, a label to call it, with arguments most of the time. And the body is the description of the rule, like all the predicates that will be called, that can be called to check the rule. So as the goals is a list of predicates, they can be they can have an and condition with a comma, or inclusive or, logical inclusive or condition with a semicolon. So here you have a very basic example. If we say mortal parenthesis x, that is true if this specific x is human and is interpreted as true. So it's some basic relationships. So here, predicates and program is very short because we will see the example just after. But basically, a program, a logic program, is just a sum of predicates, like a collection of predicates, to describe the world that we want to investigate, so to say. And the predicates themselves, they are a collection of clauses with the same name and number of parameters, number of arguments, so the arity. And here we have an example. So here we have technically 5 predicates, all those that have the same atom at the beginning. They are grouped as the same predicate. So we have mother child, father child, parent child, grandparent child, and sibling. Those 5 terms, they are predicates, and as you can see, they always have the same number of arguments if they are in the same group. They are like grouped like this for the visibility, but technically they could be without any space in between. And the first predicates are quite simple. They are actually facts as well, because as you see, they don't have any body after. And it just tells us that Elizabeth and Charles have a mother-child relationship. As you can see, we don't have any information on Charles, on the genders, on whatever. It's just like a simple link. Even the link itself says something to us because we know the term mother. But apart from that, it's just a link between those two that is true. If we call this, it's going to be true at the end. We have the same for father and child, but we have two different possibilities, two facts that we know. That William is a child of Charles and Harry is a child of Charles as well. So those are facts. Then we have some rules, more elaborated predicates with the parent child X and Y that tells us once that it can be true if the X and Y are also in a mother-child relationship. If this predicate mother-child XY is true, then the parent child for this X and Y specifically is going to be true as well. And we have another option with the father-child predicate as a condition. So both would be used separately depending on the X and Y and what can be found as a true, because the program will always look for the truth, and it's gonna look in all its database and knowledge base, so to say. The grandparent-child predicate is slightly more elaborated again, because we have X, Y again. In this case, you have to cumulate both two predicates to be true, for the first one to be also true. And the two predicates are calling twice the same predicate that we saw before, but with different variables. So it's not necessarily going to give the same result. And globally, to check if X and Y have a grandparent-child relationship, we check that X has children Z, whichever it is, and this specific Z can also be the parent of a certain of the Y that we gave as an entry. If both of those have a valid option, then the X and the Y will be returned as potential solution of this question. Knowing that in this case, the Z has to be the same entity, the exact same value, because it's the name of the variable. That's where the underscore, unique underscore variable can be used. It's a joker for a variable that we don't want to name. We don't want to care too much about the value. We just say anything that can fit this argument spot. To make the rule true, we want to get it. So we don't want to propagate the value, to keep the value anywhere. We just want a joker to check the rule. And the last one is also a bit the same as the previous one. It's like a XY sibling relationship where we check that the two arguments have the same parent, again, the Z parent. So it can be a mother-child or it can be a father-child predicate that gets true, but needs to be the same Z. Again, and the last part is a built-in predicate that is negation, just to check that the X and Y are not the same entity, otherwise the sibling relationship should not work. So based on this world, we can query the engine to get the answers that we are looking for. So the query is basically looking like the body of a clause, so without any head. No, it's actually looking at the head. Anyways, so if we are looking for Charles' children, for example, we can ask the father-child predicate with Charles as the father part and the X variable as the child, to ask the program if there is any X somewhere that fits, that validates this predicate. And it's going to give us two answers, of course, because in the world that we described, we gave already two facts that says that William and Harry are both children of Charles. So it's not going to check any other predicates because it's this father child that was called. So it doesn't care about all the others. But if several predicates validate the question, it's going to return all of them. That's the point of the querying engine. We can also use the questions to check some facts. So here we can check if Elizabeth and William have mother-child relationship somewhere. It's going to answer false, spoiler, because we have only one predicate, one fact that says that Charles is Elizabeth's child, and nothing about William and Elizabeth. So when the program doesn't know, he says no. He only tells the true facts that he knows or that he can compute with the rules that he has. So the same for the grandparents. We can, instead of checking the end part of a predicate, you can also check the first part. So if we give Harry, we are looking for all the possible grandparents he can have. So again, the chain will be computed, and it's going to give us only one answer, which is Elizabeth, based on the mother-child predicate and the grandparent-child predicate. And you can also give complete variables to generate all the potential answers that the world can give you for a predicate. In the case of sibling, for example, we will just say whichever x and y, is there any sibling pairs? There will be two answers, of course, because each variable can take two values, either William and Harry or Harry and William. In that case, it will also check that the x and y are not the same, so it's not gonna reply Harry and Harry. Without this part, it would be 4 answers, including Harry and Harry and William as siblings, which is not the real life logic. And with this, we arrive to the conclusion, which is that even in a logical program, we can still make this program say wrong things if we don't pay too much attention. So with a bit of manipulation, setting the good thing in the world that we describe, we can reach the famous statement that says that Socrates is a cat at the end. And that's it. Thank you for watching and listening.
Wow, that was interesting, but slightly complicated, but I think very useful to know. Thank you very much, Vincent.